Hi there. Welcome to the basic electricity simulation. We're having problems with the electricity in one of our lab rooms and it is completely dark. Our scientists need to work there, but they need light to do so. In this simulation you will be able to understand the most important concepts about electricity and you will even build your first simple circuit. Can you help us? This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top right of your lab pad to switch the play mode. If you disable the sound effects, the lab pad will slide up whenever there are instructions to read. You can select what type of audio you prefer. Deselecting any of the options will mute that option. Click Continue to learn how to navigate through your mission. Using the lab pad is an important way to get the most out of this simulation. Is this the first time you are playing a Labster simulation? Perfect, then let's get started with your first mission. Before we try to fix the problem, we should understand what electricity is and a few of the key concepts that surround it. Move to the hollow table to learn about electricity. Electric current is the movement of charge. Let's start with the smallest possible charge, an electron. The charge is measured in coulombs, and an electron carries the minimum amount of charge. This is 1.6 times 10 to the power of minus 19 coulombs. Click on the electron to continue. 1 coulomb is basically the charge carried by 6.25 times 10 to the power of 18 electrons, so every time that we refer to 1 coulomb of charge it means the current carried by that number of electrons. Click on the group of electrons to continue. Each of the big electrons represents 1 coulomb. Can you count the number of coulombs that are passing through this point in 5 seconds? Click the play button to make the electrons move and count the number of coulombs passing through the red area in 5 seconds. You can press the play button to see it again as many times as you need. How many coulombs pass through the red area in the circuit? Exactly. This is actually the way that we define current. Let's continue to learn a bit more about this. Current is the number of coulombs that pass through a point in 1 second. Current intensity, or just current, is measured in amperes. 1 ampere is 1 coulomb per second. If in our previous exercise 10 coulombs passed through a certain point in 5 seconds, what is the current in our circuit? Precisely, 10 coulombs in 5 seconds is the same as 2 coulombs per second, or 2 amperes. Well, actually, we won't ever have electric current unless we have a power source. Click on the circuit on top of the hollow table to add the power source. Once we add a battery, we create a potential difference. One part of the battery is positively charged and the other part is negatively charged. When both poles are put in contact through a circuit, the electrons flow from the negative pole to the positive pole. The electric current will continue happening until the potential difference of the battery is zero, which means that both poles have the same charge. You may have noticed when you buy batteries, that they have different voltages, 1.5 volts, 6 volts, 9 volts, etc. A volt is the unit of voltage and it is equivalent to 1 joule of energy per coulomb. So, a battery of 9 volts provides 9 joules of energy to each coulomb of electrons. On the other hand, a light bulb of 9 volts requires 9 coulombs per second to light up. I know, that was a lot of information, but don't worry, we are going to see how it works in a circuit. Also remember that you can check the image on the screen by clicking the View Image button or in the Media tab. Let's get hands-on. Move to the circuit table. Here you have a half-built circuit. You can place the different elements on the plates. Whenever you add a component to the circuit, you will see that its 2D symbol will be placed on the screen to your left. Place the light bulb and battery on the plates. Good job! In case you didn't realize, whenever you move one of the components from its position, it will also change in the screen on the wall. The screen on the wall shows the 2D representation of your circuit. Let's press the switch to see what happens. It seems like the light bulb has lit up, so the electricity is flowing through it, but it's very dim, isn't it? That light bulb looks very dim. Why do you think that this is happening? You can hover over the battery and light bulb to get more information. Exactly. The light bulb needs 8 volts to work, but the battery is only providing 6, so it just lit up a little bit. Let's slow this down to understand what is happening. Since electricity moves at around 300,000 kilometers per second, the electrons move through the battery, where they receive 6 volts. Those electrons travel through the circuit until they reach the light bulb, where the 6 volts are then used. Then, the electrons head back to the battery, so the energy is preserved. The 6 volts provided by the battery are used within the circuit. We have seen that the volts are used by the different components in the circuit. What would happen to the current expressed in amperes? Another right answer. Yes, the amperes are constant, the electrons don't disappear. The number of electrons is always the same. What changes is the amount of energy that they are carrying, the voltage. Very good. So now that we know how to light up this room by using a battery and a light bulb, give me 20 minutes and I will set up the circuit for you to try. Okay, seems like everything is ready. I used the same light bulb of 8 volts that we used before and set it up inside the dark room. Luckily I can see in the dark. Why don't you try to connect the 6 volts battery and see what happens? Place the battery on the plate and press the switch to see what happens. Seems like the light is too dim to light up the whole room. Let's try to fix it. Why don't you try to attach this 20 volts battery instead? Seems like 6 volts was a bit too low to make the light bulb bright enough. Switch the 6 volts battery for the 20 volts battery and press the switch. What? It seems like the light bulb has exploded. Why do you think that the light bulb has exploded? Yes, that is it. We used a 20 volts battery on a 8 volts lamp, so it couldn't handle that much energy. It seems that to adjust the voltage we need to learn about resistors. You can play the electrical resistance simulation if you want to know more about this. Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Thank you for your feedback. Your score has been saved together with your 100% progress. Congratulations, you have completed the simulation. We hope you enjoyed it and you feel wiser now.